VPN Management, the learning objectives and key concepts for VPN Management. Learning objective: describe the fundamental functions of virtual private networks, common VPN technologies, and the elements of VPN implementation and management. Key concepts: best practices for managing VPNs, VPN policy creation, VPN deployment planning for the enterprise, the general nature and source of threats against VPNs, VPN troubleshooting. VPN management best practices: build in redundancy, choose the right VPN product, develop a VPN policy, prohibit split tunneling, ensure client security, practice vulnerability management, use multi-factor authentication, document your implementation plan, monitor VPN availability, and perform regular reviews, backups, and updates. Built-in redundancies. Most VPNs use failover or load balancing. Keep a spare VPN product on the shelf, configured and ready to go live in the event of a failure. If the VPN is cloud-based, ensure redundancy is clearly spelled out and guaranteed in the contract or the SLA. Choose the right VPN product for your environment. Document your requirements. Carefully evaluate the capabilities of each VPN product for review. Check with peers if available. Review the appropriate industry literature. Avoid purchasing products based on promises rather than proven capabilities. Consider using resellers and consultants. Develop a VPN policy and prohibit split tunneling. Document our organization's rules for using a VPN. Proper policy framework is key. Prohibit split tunneling, a configuration setting that allows simultaneous access to both an untrusted network like a home network and a secured VPN connection. Potentially opens a door into the network that you cannot control, known as hairpinning. Split tunneling example would be your corporate network. In your home machine, you create a VPN tunnel across the local network. You want to tunnel everything on the home machine across to the corporate network and go out their internet. Split tunneling, if that is allowed, that would allow only the corporate traffic to be tunneled, and your internet connection through your home would be on your local ISP. What are the dangers? Well, if you're split tunneling and your machine gets compromised with a virus or an attack, then you've allowed and introduced that attack on your machine in a secure tunnel back to your corporate network. So you would securely be corrupting back to your corporate network. So that's why you want to turn split tunneling off. Ensure client security. Patch the client operating system at least once a month. Require antivirus, anti-malware, intrusion detection, and a firewall software on the organization-owned computers. Require that personally owned equipment meets specific security standards, including running an antivirus test prior to allowing access. Practice vulnerability management. Vulnerability management is a technology and business process used to identify, track, and mitigate known weaknesses on host or applications within a computing environment. Reduces risk in your computing environment. Everything is vulnerable to attack. Use tools that periodically test your environment, including the VPN systems, for missing patches, configuration issues, known exploits, and other vulnerabilities. Use multi-factor authentication. What is multi-factor authentication? It's something you know, an example of a password or a PIN. Something you have, examples would be smart card, proximity card. Something you are, an example would be a biometric device. Document your implementation plan. Document your implementation and support plans. If you cannot simply find an open rack in the data center, run a cable, plug in a device, and keep your fingers crossed. That will work. Monitor VPN availability. Typical method is to discover issues with your VPN is when users start calling for help. Use the same type of monitoring equipment you use to monitor routers, switches, and other network gear. Better to alert senior management to temporary problems than for them to tell you something is wrong and not working. Perform regular reviews, backups, and updates. Review VPN usage regularly. Consider removing access for employees who no longer use the VPN. Investigate multiple concurrent connections for a single employee. That might indicate a security issue. Suspend access for anyone who will be unavailable or not allowed to access the VPN due to corporate travel outside of the country or vacation. Back up your VPN connection and configuration regularly. Patch regularly. Restrict remote access to the organization's VPN solution. Prohibit split tunneling. Define which classes of employees can access the network by VPN. Define which types of VPN connections will be permitted. Define the authentication methods permitted. Prohibit sharing of VPN credentials. List the configuration requirements for remote host, including current virus protections, anti-malware, host-based intrusion detection systems, and a personal firewall. Prohibit the use of non-company equipment, or if personal systems may connect to the VPN, define the minimum standards for those connections. Define required encryption levels for VPN connections. If the VPN will be used for network-to-network connections, define the approval process and criteria for establishing a network-to-network connection. Have the policy reviewed and approved by the communications, legal, and human resource departments before release. Communicate the policy to the employees. Developing a VPN deployment plan. Consider these criteria. What type of VPN connections does the solution support? User access, site-to-site, or both? Which encryption protocols are supported? How many VPN connections are supported? How well does the VPN perform compared with high-speed network? How well does the VPN interoperate with your existing network infrastructure? What are the support options available from the vendor? How easy or difficult is the VPN to set up? What are the management capabilities available with the VPN? What additional features does the VPN offer? Does the VPN support failover high availability configurations? How scalable is the VPN? In this example, common VPN architecture, this is bypass mode. Traffic to the VPN and from the VPN to the internal network is not firewalled. Internally connected, traffic to the VPN and from the VPN to the internal network is not firewalled. Places the internet-facing VPN connection behind the firewall. DMZ-based addresses the main shortcomings of the previous two architectures. It includes a firewall in front of the VPN to protect it from the internet-based attacks, as well as a firewall behind the VPN to protect the internal network. Negative of this design is cost of deploying multiple firewalls. To deploy your firewall successfully, consider these points. Plan the physical location of the firewall. Ensure the selected location meets power and cooling requirements. Plan the IP addressing of the external and internal network connections on the VPN, as well as pools of addresses assigned to clients when they connect to the VPN. Plan firewall rules to permit the VPN to work. Configure the VPN server by setting up the IP address pools assigned IP addresses to the interfaces, establishing the banner message, and disabling split tunneling. Set up the authentication mechanism. Follow your organization's change management policies when deploying the VPN. Additional things. Once the VPN is on the network, create a pilot group to test the deployment. Develop an operations manual. Develop user documentation. Develop support processes. Communicate the rollout plan to management and affected employees. Install the VPN client on your any remote access users. If using a clientless VPN, configure the software. Distribute authentication credentials, tokens, and so on. And train your users. VPN threats and exploits. Hardware VPN security vulnerabilities could be a weak default password, insecure default configuration, or misconfiguration by the installer. Software VPN vulnerabilities, OS vulnerabilities, OS misconfiguration, application conflicts, instability, viruses, and malware. Vulnerabilities common to hardware and software VPN implementations could be denial of service attacks, missing patches, backdoor attacks, unpublished vulnerability in the code, weak client security, weak authentication, hairpinning, credential sharing. Commercial versus open source VPNs. Benefits of commercial solutions is ease of installation and management, available management tools, access to vendor support, and available hardware maintenance. Benefits of open source solutions. It's a low cost. They're flexible, ability to run on existing hardware, and access to internet-based support. Balancing anonymity and privacy. Anonymity, the ability of a network system user to remain unknown. Tools that support anonymous access include Tor and Viper VPN. Anonymity solutions do not always protect your privacy. Privacy, keeping information about a network or system user from disclosure. A VPN connection encrypts data that is carries and protecting privacy. Protecting VPN security and support availability. Implement 2 VPN hardware units or open source VPNs and configure each as high available pair. Protocols, Cisco Hot Standby Router Protocol, or HSRP, or Virtual Router Redundancy Protocol, or VRRP. Load balancers. When one VPN fails, the load balancer automatically directs all traffic to the remaining gateway. Redundant internet circuits and connections. The importance of user training. You need training for the IT team and support staff. They must understand how the VPN solution works, must know how to support the users. End users. Methods that you could use are training videos, conference calls, web conference, classroom training. The training plan should describe how you will train your new employees. VPN troubleshooting steps. Identify the symptoms. Determine the scope of the problem. Look for changes that were made on the device. Call the vendor. Try the most likely solution. Test it. Check whether you broke anything else. Document. You need to document everything so that you know what you've changed. And make a backup. Generally, a VPN has 2 interfaces. An interface accessible from the internet, the connection to the internal network, possibly through a firewall. To check that the VPN is still on the network, verify that both ports are functioning. Verify that the internal port is available. Use the ping command from the Windows command prompt or from a Unix command line. Validate the external port. Use a traceroute command using internet-based traceroute tools to determine whether your VPN is accessible from the internet. In this command prompt window, we can see that we have pinged the IPv6 address and that we're getting a reply from it. So that's if you look further down, that packet sent is 4, received 4, lost 0. So that was a successful communication. Using internet-based traceroute tools to determine whether a VPN is accessible from the internet. Here we can see this is a web-based solution. You do traceroute, use your IPv6 address, and we can see the hops that are going from the host that you're on the internet, the web page, to the far end host of the VPN device. In summary, we've looked at best practices for managing VPNs. We've reviewed VPN policy creation, deployment planning for the enterprise, and the general nature and source of threats against VPNs, and VPN troubleshooting.